Okay, so on this video I'm going to do this example problem here, and we're given a graph G which is made up of vertices and edges. The vertices are A through G, and the edges are given as 1, 2, 3, 4, 5, 6, 7 sets of vertices. And it's important that these are sets, in which case they are undirected edges between the vertices. Okay, and let's see, it first asks us to draw a picture of the graph, arranging it so no edges cross each other on the page. Let's see, I think that I designed this problem so that if I make the edges, or the vertices A, B, C, D, E, F, like this, and then put G over here, it makes a nice picture. And I will connect these now with these edges from, first one from A to B, next one from B to C, next one from C to G, then from B to D, then B to E, C to E, and F to G. Okay, so there's a picture, and the way I happen to lay the vertices on the page, I had no edges crossing each other. Okay, now it's important to realize that it's the same graph no matter how you draw it on the page. Okay, the layout of the vertices on the page is totally arbitrary as far as the graph goes. Okay. Okay, so next it asks, make a table showing the edges, the degrees of all the nodes. Okay, so the nodes are A, B, C, D, E, and F, and G, and here are their degrees. Okay, A has degree 1 because it only has, and what we can do is we can imagine drawing a little circle around each node and asking how many edges cross through that little circle. A has 1, B has 1, 2, 3, 4, C has 1, 2, 3, D has 1, E has 2, F has 1, and G has 2. Okay, so we did that. Is this graph a tree? And the answer is no, because a tree can't have any loops. Or we're supposed to call them cycles. And this graph has a cycle. Has a single cycle. And that cycle is this, I keep on wanting to call it a loop. It's a walk that starts and ends on its same node. Okay. And so B, C, E, B, let's call it that cycle. B, B, C, E, B. Okay. Is the graph connected? Yes, it is. And it's connected because there is a path from every node to every other node. Now, technically speaking, we have to make a list of all pairs of nodes and list out the paths between them. But this is obviously, see the figure. It's obvious from the figure that this is connected. Okay. Consider the walk ABE CBD. Is this walk a trail or a path? And here's the reminder. We have a path, we have a trail, and we have a walk. And the idea is that these are distinguished from one another by whether or not you can repeat a node or one of the vertices, or whether or not you can repeat one of the edges in the walk. Okay, so can we repeat vertices? Yes or no? And can we repeat edges? Note that it's possible to repeat a vertice without repeating an edge. And so a walk can repeat both of them. A walk, almost anything that you do as a sequence of, listing a sequence of vertices that are connected by edges, almost anything you can do is a walk. Okay? But a trail is restricted in that it cannot repeat the edges. It can repeat vertices though. And a path can't repeat either of them. Okay? And so the walk ABE, CBD, let's go ahead and sketch out that walk here. I will sketch out that walk in a black color. ABE, so I'm going to go from here. ABE, CBD, from E back to C, and then to B, and then to D. Okay, that is a walk. It doesn't repeat any edges. We first go on the edge from A to B, then from B to E, then from E to C, then from C to B, then B to D. It doesn't repeat any edges, but it does repeat the vertice B. So this thing, so the walk A, B, E, C, B, D is a trail, is not a path. And when you look at these things, when you look at these lists of vertices, what you can do is you can see it does repeat a vertex. The B is repeated. But you don't have any of the... So you have a single element in the walk repeated, but you don't have anywhere where you have the same two letters in a row. Here we have A, B. We never have A and B next to each other. Here we have B, E, then E, C, C, B, and B, D. Okay? So, we're done with that part. And let's see here. Is it a trail? Yes. Is it a path? No. Construct a path starting on node A and ending on node D. So, it asks us to construct a path. So, part F. So, this is part E. This is part B. This is part A. I did part C up here, right next to it. I did part D up here next to it. And so part F, I want to construct a path starting from A and ending on D. And a path can't repeat vertices or nodes, so I have to go, there's only one way of making this path, which is A, B, D. Okay? I can't go over to C or E. I can't go past B to either C or E because in order to get back to D, I would have to go back through node B again, and then it wouldn't be a path. It would be a trail, maybe, but not a path. So there's part F. And now part G, is it possible to construct a path starting on node A and ending on node D that passes through node E? Explain your answer. I just answered this. When I did part F. No. Explain your answer. It would have to pass through node B again. And it wouldn't be a path because it would repeat the vertex. Okay, so again, is it possible to construct a path starting on A and ending on D, from A to D, that passes through node E? Okay, the only way to get to E from A is to go through B, but then, and I could get to E a couple different ways from B, but then the only way to get back to D would be to go back through B again, in which case we would repeat that vertex. Okay, so I hope this helps.